what are the variations? And that's now what we're going to start to see. So the variation is you may have different amplitudes, you may have different period, depend on how these functions are written. For the basic function, what was the equation? So the basic function had y equals sine of x. Notice that that means that there is a number in front of sine multiplying sine, and that is 1, right? Invisible 1. And also there is a number in front of x inside, which is 1. So that's how you get just y equals sine of x. Because the coefficients in front of sine and the coefficient in front of x, the angle, they both 1, so we don't have to worry about that. When we don't have this equals to 1, that's what we call a variation from the basic, function. When these variations appears, you have different effects on the graphs that you see. You saw the graph of the basic function. So if the sine function is not multiplied by 1, let's say some other number which is called a, that a value plays a role on how vertically the function are stretched or kind of shrank vertically, and that is the value of a. That value of a, because it's affect the function vertically, it's going to affect what is called the amplitude. So we can generalize that the amplitude for any of the graphs, instead of saying it's always 1, we can say, hey, whatever a is, you take the absolute value of a. So for the basic function, the amplitude was 1 because we took the absolute value of a, and a was 1. So the absolute value of 1 is 1. So that's why we ended up with amplitude 1. And you can see this reflected in the graph because that is the vertical distance. So for the basic function, let me go back a little bit again, is this distance right here. So this distance from the top point to the center line is the amplitude, and that was 1. So when that's not 1, you're going to see that either vertically your graph is stretched or shrank. Okay, and by the way, the amplitude can also be defined as from the lowest point to the center line. So either the lowest point to the center line, the distance, or from the top point to the center line. So these are all amplitudes. So what this graph is saying is that, hey, if I don't have amplitude equals to 1, what could happen? So you can see different versions of what happens. So the red curve is the basic function. So if you have y equals 2 sine of x, notice that the amplitude is the value of the number in front of sine. Absolute value of that is 2. And you can see that is referring to the green line here. So this is the green line represents the sine, 2 times sine of x function. So if that is 3, for example, y equals 3 sine of x, the amplitude is going to be 3 because we take the absolute value of 3, which is 3. And that is the curve blue that you see. So you can see that it's more stretch for the blue than the green one. For the green curve, the amplitude is 2, so the stretch is less than the blue curve. So it could be any different number of values, and they all play a role on how vertically the function is stretched or shrank. And whatever that number in front of sine is, which we call number a, absolute value of a is actually the amplitude for the function. All right, so let's do this. Notice that now it's not anymore the basic function. It's a variation of the type 1. The variation of the type 1 is when you have y equals a number times sine of x. We're going to see the other variation next class. In this case, a is a half. So if a is a half, I know the amplitude is the absolute value of a, which means I take absolute value of a half, and that is a half. So the amplitude is a half. Now, what is the period? The period always depends on the number in front of x, and the number in front of x is actually 1. Okay, so I'm going to write here that the period of the function is still 2 pi, and it's 2 pi divided by 1, and it has something to do with the number in front of x. Okay, when that's not 1, that's going to change what is the period of the function. All right, so that's still 2 pi. That didn't change. So in order to find the 5 key points, we're going to take the period divided by 4. So we take this quantity. The quantity is the period, whatever the period of the function is. In our case right now, that is 2 pi. So the period of 2 pi divided by 4, when you simplify, you get pi over 2. So this didn't change from before. And because we don't have phase shift, we always start from 0. So we're going to graph a fundamental cycle here, which is starting from 0. If we start with 0, so we have the first x value has to be 0. The next one is the previous one plus this quantity, which is pi over 2. So the result is pi over 2. So the next angle is also pi over 2. Now I'm at pi over 2, so I take the current one plus the quantity, and then I get 2 pi over 2, and that's pi. The next one is the current one, which is pi, plus the quantity. Okay, finding the LCD and adding the fraction means you get 3 pi over 2. And I'm at 3 pi over 2, so take the current value and add the quantity of pi over 2. That is 4 pi over 2, and if you simplify, you get 2 pi. Notice that from 0 to the last fifth point is a full cycle. So you have 5 points, one for each of the axes. See, from the beginning to the last one of the 5 is always going to correspond to the full cycle. So we're still using pretty much the same. Nothing changed for this variation, but you're going to see the next variation that will change. So we use 0, the first number, and then we have pi over 2. We have then pi. We have 3 pi. And then finally 2 pi. Again, the unit circle is going to help me with the points. The y value here is going to be a half, which is 0.2 times sine of 0. We know sine of 0 is the second coordinate of these points, so 0. So you have, as a result, half times 0. The result is just 0. So the point I'm going to use is 0, and the result of this, which is 0. So I have 0, 0. The next one is pi over 2. Pi over 2 has the terminal side like this. So 1 is the sine of pi over 2. So for my function, the y value is going to be a half times the sine of pi over 2. Now pi over 2 has a sine of 1, so it's a half times 1, which is half. So the point is the angle of pi over 2. So I'm pointing out to the x value, and the y value that I get from this multiplication, which is a half. So I have pi over 2 comma. The next one is the y value for pi, the angle pi. So we have a half times sine of pi. Now the terminal side of pi, which is 180 degrees, this, and that has a sine of 0. So this computation becomes half times 0, which is 0. So the point is going to be the angle, which is pi, and the y value, which came out to be 0. The next angle is 3 pi over 2, and the terminal side of that is right here. So we're going to use the sine as a -1. So we have that y over half times the sine of 3 pi over 2. The point is the angle, 3 pi over 2, and the result of the computation, which is half times -1, -half. And finally, the last one is y equals half times the sine of 2 pi. Now 2 pi has this as a terminal side. So again, we're back to 0 for sine there. So if that is 0, this computation basically becomes a half times 0, which is 0. So the point is the angle, which is 2 pi. So we have 2 pi, comma, and the value of the evaluation, which is 0. The point 0, 0, pi over 2 a half, pi 0, 3 pi over 2 negative 1, and 2 pi 0 are the points that I'm actually going to put in the graph. So we have 0 radians here. This mark here is going to correspond to pi over 2. The next one is pi. The next one is 3 pi over 2. And then the next one is 2 pi. Tick marks correspond to 1. So here on the bottom, this is negative 1. So why am I marking 1? Because I want to actually compare the previous result with now that I have a half, and that is the amplitude, right? The amplitude is a half. The amplitude is a half, which comes from the value of A. So the first point is 0, 0. So 0 for x, 0 for y. The next point is pi over 2 and a half. So a half is somewhere around here, halfway between 0 and 1. And then you have pi, 0. So pi angle, 0 for y. And then you have 3 pi over 2 negative half, which is halfway between 0 and 1, somewhere around here. And the next and last one is going to be 2 pi 0. And again, all I need to do is consecutively connect these dots with a smooth curve oscillating like this. And that is going to be the graph of the sine, half of sine of x. Before this used to be like this. It used to go up to 1 and go coming down. So notice that there is a vertical difference there. Amplitude is the absolute value of a half, which is a half. And that is what the distance I mentioned before. So from the point here to the horizontal x, this distance is actually the amplitude. Or could be the distance from the horizontal x here to the lowest point. So either the highest point or the lowest point, the amplitude is this vertical distance to the center line. And the center line for our functions here is going to be the horizontal x.